Alright, this is a video for section 6.7 on graphing quadratic inequalities. Now, we have graphed before regular inequalities. We did that, regular linear inequalities. We did that in chapter 3. So today, it's something we've done before. The difference is that we're just going to be graphing a quadratic. We're going to have parabolas being graphed instead of straight lines. Now, a couple things to remember before we get started is that first thing's about standard form. Remember that if we have a y in our problem, this is an example where we graph. So this is what we're going to focus on in the video here, this particular video, where our equation equals y. That's an example of where we graph. If our equation equals 0, remember back to when we learned how to factor, if it equals 0, then this is an example where we would solve it, and they get solved differently. These two are different types of problems, okay? But this video is just going to focus on the graphing part. And if we have inequalities, that means we're going to be shading our graph in. We're going to have part of our graph shaded so that we can see which numbers, which points make our solutions to our graph. Now, one other thing to remember these, less than and greater than, these are dashed lines when we graph them. And if we have equal to on them, then they are solid. So when we graph our parabolas, they're either going to need to be dashed or solid depending on the inequality sign we have. Alright, so let's jump right into example 1. Example 1 says y is greater than x squared minus 3x plus 2. Now, there's a couple different ways we could solve this. You could try to factor this, and you could get the two zeros for our problem, the roots, and sketch your graph that way. That's not as accurate because you don't know how far down your vertex would be. So we're going to go through and we're going to graph by finding the vertex and the axis of symmetry and those ideas. Okay? So a couple things. Real quick, we already know this is going to be dashed because of the inequality sign. It's just greater than. So we'll have a dashed sign when we get to that point. But let's start by figuring out the vertex. Remember the vertex, we use the formula for the axis of symmetry. X equals negative b over 2a. B is already negative, so now we have a negative 3 over 2 times 1. So x ends up being 1.5, 3 over 2. Now, in order to find the rest of our vertex, we take that 1.5 and we plug it in to our problem. So now we have 1.5 squared minus 3 times 1.5 plus 2. We're going to simplify that. 1.5 squared ends up being 2.25 minus 3 times 1.5, negative 3, times 1.5 is negative 4.5 plus 2. And we can put that in our calculator. So 2.25 minus 4.5 plus 2 gives us negative 0.25. So here's our vertex. Our vertex is 1.5, negative 0.25, or negative 1/4. So when we graph this, my graph ends up being my vertex right about there. So I went to the right 1.5, and then I went down about 1/4. Okay, so there's my vertex. Next thing I want to do is figure out one number on each side. So I'm going to choose a number greater than 1.5 and a number smaller than 1.5. Those numbers are going to be 1 and 2. Pick nice numbers, and I'm going to plug those into my problem. So now I have 1 squared minus 3 times 1 plus 2. Well, 1 squared is 1. 3 times 1 is 3, so 1 minus 3 is negative 2, plus 2 is 0. Did that in my head. You can put it in a calculator if you need to. Now we're going to do 2. 2 squared is 4, minus 3 times 2 is 6, so now we're at 4 minus 6 is negative 2, and add 2 to that, we get 0 again. So then my other 2 points go right here. Alright, now I connect these and make a graph. Remember, my graph has to be dashed because it's just greater than. And then I'm going to have to figure out how to shade this. And to shade it, I'm going to choose a test point. Now, choosing a test point can be tricky for some people. I'm going to give you some pointers, and I always want you to follow these pointers. I want you to always choose a test point that's inside your parabola. That's the first rule. 0, 0 is always the best, but if it's not inside your parabola, I want you to choose something that's on the axis of symmetry. That means it's directly above or directly below your vertex. The reason we do that is because you can be sure that that'll be in the parabola. When you freehand the parabola, it can get kind of tricky where what points are actually inside and what points are actually outside. So, if you can tell for a fact that 0, 0 is inside, you want to choose that. If you can't tell, then I want you to choose a point that's on your axis of symmetry, either directly above or directly below your vertex. So here's my vertex. I'm going to choose this point here, because I can tell that's 1.52. I can tell that that's going to be on my axis of symmetry, and I can tell by looking that that's in the parabola. So now, this is my test point, 1.52. I'm going to plug those in, and I'm going to figure out if it makes my inequality true or false. If it's true, I want to shade inside. If it's false, I want to shade outside. Okay? It's always going to be that because we are always going to pick a test point that is inside of our parabola. So let's finish this. Y is 2. 2 is greater than 1.5 squared minus 3 times 1.5 plus 2. Now, if you notice, I've already done this before. I did this earlier when we figured out what our vertex was. That's why we always want to choose something that's on our axis of symmetry, okay? Because we'll already have done part of this before. So now we end up with 2 is greater than negative 0.25, and this is true. So we're going to shade the inside of our parabola. And that would be the solution. This is actually the solution to the problem, the graph. Okay? All this other stuff helps you get the graph, but the solution is the graph itself. Okay? Now, we're going to look at, real quick, a system of quadratic inequalities. And it's just like a system of equations. System of equations was two equations that we put on the same graph, or a system of inequalities. Two inequalities we put on the same graph. Here, the difference is we're going to have quadratics. So we're going to have two parabolas that are on the same graph. And when we have a system, we want the overlap. Remember, our solution is the overlap of the two graphs. So that's what we're looking for. If there is no overlap, then the answer is no solution. All right? So, I'm going to start with the first one here. First thing we notice, it's y is greater than x squared minus 4. You want to notice that it's going to be dashed. Okay? Because the inequality sign is strictly greater than. Now we're going to figure out our axis of symmetry. B is 0, so it's, remember our formula is negative b over 2a. B 0 over a is 1, so 2, but that's still going to be 0. So the first part of our vertex is 0. Second part, we plug 0 in. 0 minus 4, 0 squared, but 0 squared is still 0, so 0 minus 4 is negative 4. Alright, so there's my vertex. Now I'm going to do something a little different here. I'm going to go ahead and freehand this. The reason I'm going to freehand it is because my axis of symmetry is 0. When my axis of symmetry is 0, it's very easy for me to tell the left and the right, figure out which they're going to be evenly. So, I'm going to put my vertex at 0, negative 4. Then we're just going to freehand it. And I've already made a mistake here. Notice I made it solid. This should be dashed. So I'm going to go through and I'm going to put, so it looks kind of like a curved railroad track, but dashed on there. Okay? Needs to be dashed. Now we'll test this. We're going to go ahead and test it. And we're going to use 0, 0 because we can obviously tell 0, 0 is inside of our parabola. So we get 0 is greater than 0 squared minus 4. 0 squared minus 4 is going to be negative 4. We solved that earlier. And this ends up being true. So we will shade the inside of this parabola. Okay, so we're going to shade the inside, but I'm not going to shade the inside until I've graphed the other one. Because I'm looking for the overlap, and I want to make sure I get the graphs done correctly so that I can tell where the overlap is. But we know we're going to shade the inside of that first parabola. So look at the second one now. We have y is less than or equal to negative x squared plus 4. What's got it equal to on it, so we know it's going to be solid. We're going to find the axis of symmetry. Ends up being negative, there is no b, so negative 0 over negative 1 times 2 is negative 2, but that's still 0. So we have 0. We're going to plug that in. Negative 0 squared plus 4 ends up being positive 4. So here's my vertex for my second parabola. I'm going to put that point right here. Solid parabola this time. Okay, and I freehanded it. Now I'm going to test. And I can use 0, 0 as my test point on this one also, because it's definitely inside of our parabola. So I plug that in. 0 is less than or equal to negative 0 squared plus 4. That cancels itself out. So 0 is less than or equal to positive 4. True. So we're going to shade the inside of this parabola. So I'm going to shade the first parabola going vertically, and I'm going to shade the second parabola going horizontally. First parabola would be shaded like this. Second parabola gets shaded this direction. And we're looking for the overlap, remember, the overlap of both of them. So that would be this intersection here in the middle. And that would be the solution to our problem, that football-looking shape. Okay? And that's how we solve a system of quadratic inequalities. Just make sure that you pay attention to solid and dashed. I made that mistake when we were going through the notes, so make sure that you pay attention to it when you're doing your homework, okay? Because it's important whether you get a solid or a dashed parabola. That does change your answer. Dashed means we don't include the numbers on the parabola. Solid means we do, so it does change your answer, okay? Again, if those are your notes for section 6.7 on graphing quadratic inequalities, if you have questions, go back and rewatch the video. If it doesn't answer your question, bring it to class next time.